Welcome back to part two of one proportion confidence intervals. I'm Professor Bedrero. And remember that we were talking about the color of M&Ms or proportion of M&Ms that were blue. In the morning class from my statistics group, about 24.8% were blue. And the sample from the afternoon class was 0.228 or 22.8%. Notice that both of these were quite close to the actual population proportion of 24%, but they weren't exact. So one was too high and one was too low, and the variation is due to just random chance in taking samples. So in this case, we were able to find data from the company to know what the true proportion was so that we could compare it to our sample proportions. But in real life, that's usually not the case. So if we're surveying people, we usually take a portion of the population and survey them, but we don't have a company that can tell us what everybody would say. So that's why we do samples. And because of that, we're going to take our sample number and know that he's going to be close to the true number. But how close? Well, based on probability and how close and a certain confidence level our number will be how close we'll be to the true number is something we call the margin of error. You might have seen this in reporting about political elections and the proportion of votes people are going to vote for Donald Trump or Bernie Sanders or whoever. Okay, so when we do this, we typically use what we call a 95% confidence interval. And that gives us our margin of error, or how far we think we are off at most from the true number. So to get a visual on this, we take and do our sample number, and we think that's going to be close to what the true population number is going to be. And then we find this margin of error E, and we give ourselves a little bit of cushion on the one side and on the other side. So we take our p hat and subtract our margin of error, and we take our p hat and add the margin of error. That gives us the lower bound and upper bound for an interval where we believe the true population proportion lives. Let's do that with our example with our M&Ms. So with the morning class, and we took the M&M data, we had 53 blue out of 214 total M&Ms. So we found out that p hat was 0.248 or 24.8%. To find the margin of error for a 95% confidence interval, we're going to use this formula right here. And capital E again stands for margin of error. And this is going to be representing for a 95% confidence level. And we're also going to need, in addition to p hat, we're going to need 1 minus p hat. So let's take just a second and do 1 minus p hat, which would be 1 minus 0.248, and that will give us 0.752. So let's use a calculator to find this margin of error, and let's see if that will show up pretty good there. So we're going to do 1.96 times the square root, and I'm going to put a parenthesis here so we can do the whole top, and then we'll divide by the bottom and then close the square root parenthesis for the whole thing. P hat was 0.248 times 1 minus p hat is the number 0.752. And let's close that top. We'll divide by the bottom, which is n, which was 214 total M&Ms, and then close the square root and find out that our margin of error rounded to 3 decimal places would be 0.058, because this 8 rounds that 7 up. So 0.058. Okay. So to form our confidence interval, or the range where we believe the true population number lives based on our sample data, we take our sample proportion, 0.248, and add and subtract the margin of error to get the lower and upper bounds. Okay. So if I do 0.248 minus 0.058, we will come up with 0.190. And our upper bound, if we take our p hat and add the margin of error, we get 0.306. So finding the confidence interval is important, but even more important is what he means. So we interpret this by saying we are 95% confident that the population proportion of blue M&Ms is between 0.190 and 0.306. If you prefer percents, we would say we are 95% confident that the population proportion of blue M&Ms is between 19% and 30.6%. And we have a visual here on a number line, okay? And if we mark the actual population proportion of 24% on here, so let me mark that. That would be little p, the true population proportion, if we were to be able to measure all M&Ms. And notice that that landed inside our confidence interval where we predicted that the true number would live. And so yes, that is inside, and that's the beauty of a confidence interval. It narrows down where we think the true population number will be. And as you can expect, we can also use technology to help us with these calculations. So let me pause for just a second. If you go to this web address, https://epitols.ausvet.com/CIPROPORTION, you will get an applet that brings up an applet that will help us find confidence intervals. So let's fill in our numbers here. Our sample size was a total of 214 blue M&Ms, of which 53 were blue. We're going to use a 95% confidence level. Note that you can change that, but we're going to stick with the convention of 95%. And we're going to use the normal approximation or Wald method, and we'll leave 4 decimal places in our answer. So if we hit submit, it's going to think about that for a second and come back, and at the top, it's going to give us some information. So let me have you write that down in the space where it says record results here. So we'll pause the video right now. So after you've written that down on your paper, let's switch back to our document camera so we can actually see that. Okay, so notice that the lower limit, or the lower bound, is 0.1898, which when we round to 3 decimal places is the exact same as what we found earlier, 0.0190, and 0.3055 is the same as what we found earlier at 0.306. So we would be able to now interpret this as saying we are 95% confident that the proportion of blue M&Ms in the population is between 0.1898 and 0.3055, or between 18.98% and 30.55%, which rounds to the exact same thing as we did earlier. Okay, so let me tell you that Weird Al Yankovic is one of my favorite musicians, and here's the latest album I have from him. It's called Mandatory Fun. Now, take a minute and find and interpret the 95% confidence interval for the proportion of blue M&Ms in the afternoon class. Then we'll come back and see what you did together and finish our video. Okay. So hopefully you got the following information. That mainly the thing that we need the most is the lower and the upper numbers. So we will now interpret this and say that we are 95% confident, based on the afternoon sample, that the population proportion of blue M&Ms is between 0.1640 and 0.2911, or if you prefer percentages, 16.4% and 29.1%. Okay. Now notice that these numbers were a little bit different from what we had earlier. That's because we took a different sample. But notice also that the true population proportion of little p being 0.24, or in other words 24%, was still inside this interval. And that's the nice thing about confidence intervals. They narrow it down, and if somebody else does a different sample, they might get slightly different numbers, but we're usually pretty confident that this new interval and the other interval will both contain the true population number. Okay, and that's it. So make sure you do the homework on Canvas, and you get 2 attempts, but I'll take the second attempt if you try it. So don't try to game the system. Okay, see you in the next video where we'll learn about risk homeostasis.